All right, guys. I'm going to do an example now of how to do problem number one. This is the acceleration practice worksheet. So let's read through this. It says Tom's car leaves a stoplight at t equals 0. His velocity changes at a constant rate from 0 meters per second to 40 meters per second over an 8-second time interval. Okay, so the first thing it wants me to do is draw the velocity versus time graph for Tom's car. Now I'm going to do this over on this graph to the right here. Um, so I'm just going to grab my pencil tool here and let's look at the important stuff. So I know one thing. So Tom's car starts moving at t equals 0. And when t is 0, I know that his velocity is 0 meters per second. So that's where it starts off at, is when t is 0. We need to label this thing. So I've got my time axis is labeled, but I don't have my velocity axis labeled yet. So I know that velocity needs to get up to 40 meters per second. So if I go over here and I count, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So I'm just going to go ahead and count by fives. I think that'll take me up to 50, and that'll be just fine. So I can do this. I can go 5, 10, 15, 20, 25, 30, 35, 40, and that's good because I needed to include 45 or 40, and then there's 50. All right, so sorry about that. Okay, so I know that my yellow highlights at t equals 0, then my velocity is also 0. So I'm going to put a dot on my graph, and since I labeled in that color, I'll put my dots in purple. So I'm going to put a dot at 0, 0. All right, good. Now I see that I already have orange. Let's see, red. All right, so I see that his final time or his final velocity is going to be 40 meters per second, and it takes 8 seconds for that to happen. So what I'm going to do is I'm going to take my pen again, and I'm going to go 8 seconds, and then 40 seconds. All right. So we see that's 8 seconds and 40 seconds. All right. I put another dot. Okay, so now I just want to connect my dots. So I go like this, and there we go. I've got my velocity versus time graph drawn. That makes sense, okay, because I've got positive velocity. I'm moving away from 0, and I've also got increasing velocity, so that uphill slope means my velocity is increasing. Now it wants me to calculate the acceleration, so let's go down here and do that. Well, I know that my formula for acceleration is A equals VF minus VI divided by TF minus TI. So what I'm going to need here are VF, VI, TF, and TI. So let's look at my final and initial velocity. When I go back up here, I'm going to look and I'm going to say that my initial velocity is 0. My final velocity is 40 because I'm starting at 0 meters per second and I'm ending at 40 meters per second. So notice that I put my 0 next to my VI, my 40 next to my VF. Make sure we're not getting initial and final mixed up. And then it wants TF and TI. So when I look in here, well, I know that my initial time is 0, so I start off at 0, and then it takes 8 seconds, so my final time is 8. All right, so when I go to plug those in now, I've got A equals, VF is 40, VI was 0, TF was 8, and TI was 0. So notice what I did there, okay? So 40 and 40. Okay, 0 and 0. I'm just kind of showing you where these things match up. All right, 8 and 8, and blue. Okay, 0 and 0. So I see that my VF matches to my red, which is 40. My VI matches to my orange, which is 0. TF matches to my green, which is 8. And TI matches to my blue, which is 0. All right, and so after I calculate all of that, I'm going to get 40 divided by 8. When we do that on the calculator, what we're going to get is 5. Now remember, this is really important, okay? So my unit is going to be meters per second squared. 5 meters per second squared. Okay, that's it.